That's actually kind of ironic because for the last part of the other classes, we've been very heavy-handed on batteries always increase, large system economics, but that's not necessarily true. Selling a 15 kilowatt batteryless solar array to a large diesel powered off grid community can have a quicker payback than selling them a 200 kilowatt solar array that would also require an energy controller and a battery. But really, the camp's power needs are being provided by the generator. So they don't need more power, they just need less energy consumption by the generator. And batteries store electricity for dispatchable power. Solar generates electricity for rechargeable, reusable energy. And so if energy is really the primary cost here, they're not on demand charges. They already have the power capacity from their generator nameplate ratings. It's the energy side here where the cost is. Now we've come back to an application where it's really the solar panels that are generating the cost savings and not the battery itself. So sticking to a smaller application where you don't need the batteries might be more cost effective than a system 10 times larger where you're also having to buy 20 times more infrastructure because of the battery component, at which point you might just slam on the gas and go to a system 100 times larger that does all the solar they need to offset the entire camp, which might be a 1 megawatt solar array. And you get into complicated, well, where's this array going to go? A much more complex design issue, not one that is without a solution. But what's interesting is that we've been talking about the value of batteries as opposed to solar for larger applications. And then when we get back into off grid, large facility camps, it's the energy component comes back into play.